Welcome to the Explainer. So if you're an AI professional, a software engineer, or a data scientist, you probably remember how Claude Code started out, right? It was this really capable, but let's be honest, pretty straightforward terminal coding assistant. You type in a prompt, it would spit out some code. Boom, simple. Well, fast forward to 2026, and wow, that architecture has undergone a massive evolution. We're definitely not just dealing with a simple tool anymore. Claude Code is now this fully fleshed out, layered agentic system. It's a whole different beast. Today, we're going to navigate exactly how this system works. We'll break down how it separates memory, skills, and tools into these distinct layers, and most importantly, how you can master its extensibility to literally scale your own engineering workflows. Let's get into it.
Here's our roadmap for today. First, we'll look at the shift from assistant to agentic system. Second, we'll cover the 6 extensibility primitives. Third, choosing the right tool. Fourth, safety and auto mode. And finally, number 5, some real-world engineering scenarios.
Okay, let's dive into this. Section 1, from assistant to agentic system.
To really wrap our heads around the 2026 version of Claude Code, we've got to completely upgrade our mental model of what the software is actually doing under the hood. Seriously, if you're still treating Claude Code as just a basic terminal chat prompt, you are completely missing out on the engine that drives the whole thing. The reality of 2026 is that Claude Code runs on a continuous agentic loop. It's not just sitting there twiddling its thumbs waiting for your next text input. No, it's actively choosing tools, it's accumulating context, and it's managing these really long, complex sessions through automated compaction. So instead of a single, flat layer where everything just sort of happens all at once, the system now separates memory, hooks, skills, and plugins into distinct, manageable layers. And this is absolutely crucial because each layer fundamentally changes what the model can see and what it can actually do inside your environment.
Moving right along to Section 2, the 6 extensibility primitives.
Think of it like this. If the agentic loop is the powerful engine, these next elements are your steering wheel and your pedals. As developers, we steer and extend the system using a really specific set of primitives. There are 6 core extensibility primitives in your toolbox right now. First up is the Claude.md memory file. Basically, think of this as the agent's constitution for your repository. It anchors your conventions every single session. Next, we have skills, which bundle your domain logic and helper files. Then come subagents. These are specialized instances running with their own isolated context windows, super handy. We've also got slash commands for quick type shortcuts, hooks for firing off deterministic scripts at specific points in the lifecycle, and finally, MCP servers. That's the Model Context Protocol, which connects Claude to external tools. You know, things like GitHub, databases, web browsers, the whole shebang. And what's really cool here is that all of these can actually be bundled together into versioned plugins. So you can just install an entire suite of capabilities with literally a single command.
All right, Section 3, choosing the right tool. Having all these tools is fantastic, right? But a huge pain point in the community right now is people getting confused about when to use a skill versus a hook, or a subagent versus an MCP server. So let's clear that up right now. Now, what's really interesting about this breakdown is how clearly it separates the function of each primitive based entirely on where it lives and how it executes. For instance, a hook is event-driven. It fires at defined points like, say, a pre-tool use checkpoint, and it runs deterministic code. That is perfect for enforcing hard rules without any risk of AI hallucination. A subagent, on the other hand, is built for isolated, parallel tasks. Why? Because it has its own entirely separate context window. That means all its verbose, messy work won't pollute your main conversation. Love that. And an MCP server? Well, that operates as an external process entirely. It handles all the nitty-gritty integration with your databases, while Claude simply sits back and reasons about what to actually do with that data.
The official guide actually gives us this brilliant rule of thumb. And honestly, it is the ultimate cheat sheet. You really need to commit this to memory. Okay, here it is. Use a slash command for a prompt template. Use a skill when there's real domain logic or helper files. Use a subagent for isolated, parallel work. And use a hook to enforce a rule with code. Seriously, if you just internalize that core logic, you are going to be building incredibly efficient, super clean extensions in no time.
Let's pivot to Section 4, safety and auto mode.
Okay, so handing an AI agent this massive, extensible toolbox that can execute code and dig into your databases, yeah, that requires some serious guardrails, no question. In the 2026 update, Anthropic introduced auto mode as a research preview. But, and this is a big but, they didn't just let the main model run wild. No way. Auto mode is strictly, and I mean strictly, gated by a dedicated Sonnet 4.6 classifier.
Here's how that actually plays out in practice.
Every single action the agent wants to take has to go through this specific security checkpoint workflow. First, the primary agent proposes an action, like, hey, I want to edit this file, or let's run this bash command. Second, that Sonnet 4.6 classifier intercepts and reviews that exact action. Step 3, if the action is safe, boom, it proceeds. But if it's deemed risky, like say it's trying to delete a critical directory or something wild, it gets immediately blocked or it escalates the prompt right back to you for human approval. When you combine this active classifier with OS-level file system isolation, network sandboxing, and these strict managed permission modes, you get a highly secure execution environment that you can actually trust to do the work autonomously. It's a total game changer.
Which brings us to our final part, Section 5, Real-World Engineering Scenarios.
All right, so we've got the engine, we've got the tools, and we've firmly got the safety brakes installed. Let's take all of this high-level architectural theory and apply it to your actual day-to-day engineering workflows. Scenario 1, code-base onboarding. We've all been there, right? You join a new team, you clone this massive, totally unfamiliar repository. Well, instead of digging through thousands of files manually, you just spin up an Explore subagent. Now, because a subagent can restrict its own tools, you can explicitly set it to read-only. It then uses the project's cloud.md file as an anchor so it understands the build and lint commands, and it literally maps the entire repo for you, all neatly contained inside its own context window. It safely explores the codebase without any risk whatsoever of accidentally altering production files. How cool is that?
Moving on to Scenario 2, and honestly, this is the holy grail, overnight refactors. You can actually enable auto mode for a really clearly scoped architectural change. You do this by utilizing the sandboxed bash tool with the run_and background flag, which lets Claude execute these long, heavy shell commands and just pull the output. So the crucial point here is that Claude Code automatically creates these state snapshots, or checkpoints, before it actually makes any changes to your files. So let's say you wake up the next morning, grab your coffee, and you realize the overnight output drifted a bit from your original intent. You literally just press the escape key twice. That's it. And the system completely rewinds to the last good checkpoint. It makes these massive, overly ambitious refactors incredibly low risk to try out.
Next up, we've got continuous integration. Because listen, Claude Code isn't just confined to your local desktop IDE anymore. By using the headless CLI command, that's Claude-P, you can run Claude as a one-shot process without a TTY, basically meaning no interactive terminal is required at all. You can drop this directly into your GitHub Actions. You just pipe inputs, like a git diff, for example, straight into the headless process, and Claude can automatically lint, test, or summarize your pull requests. You can even tie in those pre-tool use hooks we talked about earlier to enforce your team's security policies automatically, on every single commit.
And this brilliantly illustrates exactly how the community is starting to build out these wild, dynamic workflows. For things like customer feedback pipelines, engineers are taking these massive, complex tasks and breaking them down into much smaller steps using subagents. And then they're just chaining these reusable skills together. In a single pass, Claude can read a massive volume of raw user feedback, seamlessly trigger a categorization skill, generate a perfectly tailored response, and even route the tricky escalations to a human. It takes what used to be an absolute manual triage nightmare and turns it into this beautiful, seamless modular pipeline.
The shift from a simple chat prompt to a fully layered agentic system, it completely changes what is possible in software engineering today. By mastering these memory files, the hooks, subagents, and MCP servers, you aren't just writing your code a little bit faster, you are literally architecting intelligent, autonomous systems right inside your repository. The tools are all right there, just sitting in your terminal, waiting to be used. So the only question left for you is, out of everything we just covered, which workflow are you going to automate first with your new agentic toolbox? Dive in, start building, and take full advantage of this incredibly powerful architecture. Catch you next time.